Okay, welcome to the problem section for more on identities. And the first problem that we have says, write cosine of theta in terms of sine theta only. Of course, cosine theta is as simple as it can get, so they're not asking us to simplify this, but we're supposed to write in terms of sine only. Well, there's a relationship between cosine and sine, and that's a Pythagorean cosine squared plus sine squared equals 1. And we solve for cosine, so we're going to come up with the square root of 1 minus sine squared theta. And in order to figure that out, we would have to go back to the Pythagorean theorem that we have memorized for cosine and sine, and then do the algebra on that one here. And as we take the square root, we come up with plus minus, which of course is the equivalent form that we encountered in the past section. Okay, I'm going to scroll a little bit down here. And then we're supposed to do the same thing with the other ones here. Cosecant theta has to be expressed in terms of sine theta. Well, that's simply going to be 1 divided by sine theta. That was quick. Cotangent theta. Well, that would be then first cosine theta divided by sine theta. And then we have to do something about that cosine because it says that write in terms of sine theta only. Well, we just did a couple of exercises ago, figure out what we can do with the cosine. So here's what we're going to do. We just substitute that in there, and I'm too lazy to write this all down again, to type it out. So I'm just going to borrow it from up here. Go in there and plug it in there. And obviously that looks way more complicated than when we started out with, but that was the condition. We're just supposed to get the hang of substituting and using with identities. I'm not sure why there's such a big gap here. I don't think it really matters to me. It's off the screen and let it get back onto the screen. Oh well, it really doesn't matter to me that there's such a big gap in there. Yeah, I'm not going to deal with it now. Okay, secant theta. Well, secant theta is the same as 1 over cosine theta. And I use the same identity as I did a moment ago. So 1 divided by all of that. There we go. That's what we're supposed to do. The next exercise says, write in terms of sine theta and cosine theta, then simplify. So we're going to go in here. We write tangent theta, of course, as sine theta over cosine theta, and add 1 over cosine theta. Okay. Now you have to be careful with the algebra. This is not trigonometry, this is just algebra. Notice that we already have a common denominator, which is cosine theta, so don't multiply it. It's not cosine theta squared, it's simply cosine. And nothing happened in the numerator, so it's going to be sine theta plus 1. Again, be careful here, don't do anything with it because there is no identity for sine theta plus 1. There might be something if it had said sine squared, especially if it would say sine squared minus 1, but it doesn't say that, so this is it. Okay, next exercise, write in terms of sine theta and cosine theta, then simplify. It's a little longer. I think I'm going to go straight to the next line here. and manipulate it. Okay, the cotangent theta is going to become cosine theta divided by sine theta, and we will see that just a moment we can cancel that. Oh, that's going to look neat. So here sine theta canceled, so we're going to have cosine theta plus cosine theta, which of course is 2 cosine theta. Okay. Let's do the next exercise, and then actually we'll be splitting it up into 2 exercise sections because I want to show something. I didn't open my graphing calculator, it wasn't really necessary, but I still want to show you something with these here when I'm done after the next exercise. Okay, so this one here says, and I might be running out of space, so I might as well go on with a little space here actually. Okay, secant theta is of course the same as 1 over cosine theta, and then tangent theta is the same as sine over cosine There we go. We already have the same common denominator. We have cosine theta. I might as well start a new fraction here. That's the only thing we have in the denominator, so cosine theta, so nothing happened to the numerators. So we're going to have a 1, and then we're going to have a minus. Sine times sine, of course, is sine squared. There we go. Sine squared. And then actually, I forgot the equal sign on the very front here. And then we could say, hey, we're done, but look at this here, 1 minus sine squared. That is a Pythagorean identity. The denominator stays the same, cosine. And the numerator is going to be cosine squared. Remember, Pythagorean identity. Okay. And notice that on the very last line here, this simplifies to something really nice. That equals cosine theta. Okay. At that point, before I go ahead with the other ones, I'm going to interrupt myself. And as I continue my worked out problems, what I will start out with is these examples or problems A, B, C, and D. I will have next time around the graphing calculator open, and we'll actually take a couple of numbers and plug them in there and see that I actually came up with the right thing. I'll show you in the next section, in the next workout problem section. Okay, welcome back to this section on working out problems for worn identities. And before I go on with the next exercises, I like to use the graphing calculator and plug in some numbers to see that we actually did come up with the correct identities here, that we did the algebra correctly. On this first one here, on the problem A here, I'm just going to test this particular one here because the next one, we know that that is indeed correct. And here, as we know that cosine over sine is indeed cotangent, and then we substitute the square root here for the cosine. And we kind of see that. So if the first one is correct, then the third one and the fourth one are correct, and the second one we can see it anyway. So I'm just going to test the first one on the graphing calculator, and then I'm going to go, while I am on the graphing calculator, I go ahead and test this one here, plug in tangent plus secant, see if that indeed is sine plus 1 over cosine. Then I'm going to test this one here, that indeed is 2 cosine theta, and then I'm going to do the fourth exercise that we did, that this one here indeed comes out to be cosine. Okay, so let's go ahead on the graphing calculator. The only thing I cannot do, I cannot open both Word and the graphing calculator at the same time. So what you would have to do is either have them in your hand from a moment ago, or you have them written down on the side, and that's what I did. I have them written down on the side, and at this point, actually, I would like to open the graphing calculator. There we go. All right. So the first one said cosine. So I'm going to plug in, for example, 20 degrees. We will soon learn that the special angles are 0, 30, 45, 60, and 90 degrees. So let me take something odd like 20 degrees. Hit enter. See what I come up with, 0.408. No, that doesn't sound right. Let's go to mode. It's correct in radians, but we want to be in degrees here. There we go, degrees. Make sure that whatever is required, degree or radians, that's what you have. So let's try this again. Cosine of 20 degrees comes out to 0.94. Let's keep that in mind. It said that when we manipulated it, we came up with the plus or minus square root of 1 minus sine of 20 degrees squared. And let's see what we come up with. 0.94, right on the money. It said that we could come up with a plus or minus. Well, let's see. When I put a minus in front of that, well, obviously, I will come up with a negative at the end. So, whoa, that was interesting. What happened here? Oh, I know. Bummer. Alright. I know what I did wrong. Takes a little practice to remember how to do this correctly. I forgot to second insert that negative, so instead I overwrote the square root there, and it didn't like that. So negative 0.94. Well, that's not the same as 0.94, but if I used cosine 160 degrees, then I come up with negative 0.94. So let me put in 160 degrees into this one and see what I come up with. 1, insert, 6, right on the money, negative 0.94. As I said, I'm going to skip the next 3 because once we have figured this one out, then the other ones have to be correct as well. So the next one is exercise B that I'm going to do, which says tangent of, let's use some kind of angle, maybe 35 degrees. Tangent of 35 plus the secant of 35, which I cannot do, so I have to do 1 divided by cosine, which is the same as secant. I come out with 1.70. Now I'm going to do the same thing with how I manipulate it. So it's going to be sine 35 plus 1 divided by cosine of 35. Ooh, did I do something wrong? I don't remember doing anything wrong. Let's see, maybe I did something wrong in the when I typed it on here. That's interesting. That was kind of unexpected in my confidence. What could have possibly gone wrong? I got the secant. I'm right on the money. What did I do wrong? Oh, I see it. 1.92 is the correct answer, and watch what I did just prior to that. I didn't type in 35, I typed in 355. Whoops. There we go, 1.92. Right on. That's a way also that you become familiar how to troubleshoot, how to figure out where did I make a mistake, and accidentally, I didn't mean to intentionally, I just showed you how to do it. Try to figure out what did I do wrong, what accidentally could have happened. Okay, a couple more. It says sine of some kind of angle, 11 degrees maybe, sine of 11 times cotangent of 11, in which case I'm just going to divide by the tangent, because it's the same as multiplying with the cotangent, so tangent 11, plus the cosine of 11, plus cosine 11, and we come up with 1.96. I think I hit the enter button twice accidentally. Then I'm going to do what we came up with on the right hand side, which is 2 cosine 11, and indeed come up with 1.96. And the fourth and last one I wanted to check on the graphing calculator. So this kind of checking here kind of tells us that when I plug in a number on the left and side of the identity that I came up with, or what I simplified, and I plug it in on the right hand side, that the two results have to match. So it's a nice, quick check. And I have to admit, I do that all the time in my work in math and physics. So the last one here says 1 divided by, where's my, just 1 divided by cosine, because it's a secant, so 1 divided by, whoops, cosine, what do we use here? 22 degrees. Types itself fairly fast. Minus tangent of 22 times sine of 22, and we come up with 0.93, and then we came up with, when we simplified it, simply cosine. So cosine of 22 comes out to, oh, well, that's interesting too. How do I do that? 0.927. I don't remember making a mistake either there. They're relatively close, but they should be exact. Why are they not exact? Did I jot down something wrong? Did I type in something wrong? What did I do? Geez, second time this happened. Secant is the same as 1 over cosine, and then I subtract tangent of 22. Oh, yeah. Gosh, I mean, another little mistake here. It's a whole lot easier on a real graphing calculator to type with my fingers than it is here with the cursor to move around. Here's where I made my mistake by trying to move around with the cursor. I forgot to close the parentheses behind the tangent. So I do that right now, and I come up with 0.927, just like it should be. Okay, with that I have finished these exercises, and I'm going to go ahead with the next ones. Okay, so I just showed these last 4 exercises that they're correct. Okay, this one here. Let's see what we're going to come up with. As we multiply here, let's see, my equation editor tries to open. There it is. We're going to come up with sine squared, of course. Sine squared plus 4 sine plus another 3 sine, so plus 7 sine theta plus 12. That was simply, was it FOIL or factoring? Oh, it's FOILing. There we go. And you can check that it is correct. Sine squared right? First, then outer is 3 sine, and then inner is 4 sine, which is a total of 7 sine, and then plus 12. 3 times 4. I don't think we need to check that later on the graphing calculator. We can be confident that we did the algebra correctly on this one. And I'm looking in the solution, and that is indeed correct. On the next one, when we multiply, we're going to come up with 8 cosine squared. And then we're going to have minus 5 times 2 cosine theta, so minus 10 cosine theta plus 3 times 4, so 12 cosine theta. So minus 10 plus 12 is 2 cosine theta. Minus 15. So there we go. And again, we should be confident that we did the algebra correctly and don't need to check that later, because we should know how to FOIL. Okay, whoa, now it gets more interesting, right? We have square root of x squared plus 4, and we're supposed to simplify that by using x equals 2 tangent theta. I'm just going to double check this one here. Then I have the correct problem, and I sure do. So I'm going to rewrite this here. But now I'm supposed to plug in here 2 tangent theta. What are we going to do now? Well, not only was the point why they gave us 2 instead of any other number, because when I square that 2, I come up with the 4, just like I have here. So what I'm going to come up with is the following. Actually, do I do that on the next? I think I will do that on the next line, yes. Because I might be running out of space otherwise. Okay, let's see. So here I'm going to have 4 tangent squared. I'll put the square right here. There we go. Then I factor out the 4, and I'm actually using way too many steps here. I could have done this all in one step instead of 3. So I factor out a 4 times parentheses, and when I factor out the 4, what's left is tangent squared plus 1, and then I will again use a new line. I will take all of this off. So I take the square root of 4, which of course is 2, and then I'm going to look at what is tangent squared plus 1. Well, that's a Pythagorean identity, isn't it? That comes out to tangent squared plus 1 is the same as secant squared. So it's a square root of secant squared, and taking square root of a square, of course, is just a secant of theta. This one here we will test later going to the graphing calculator in just a little while. Just to make sure that we got it correctly. Okay, the next exercise says show that I'm just trying to check myself here that I did it correctly. And the solution manual. Oh, just a slight mistake. I should put absolute value bars around this secant because I could have come up with plus or minus there. I don't see them right here, so I'll try to do this. Oh, I opened the equation editor. There we go. Almost there. Where is it? Where are they? I'm looking for the absolute value bars. Oof. What did I do now? It wasn't patient enough with me. I'll try this again. There they are. Found it. So as I said, I will check this out later. Show that the statement is an identity. So show that cosecant theta minus sine theta equals cosine squared over sine. Which side to manipulate here? The more complicated looking side, but which side is more complicated looking? I think I just have with a preference for the left-hand side. I'll see what I come up with. Okay, cosecant theta is the same as 1 over sine theta. That's me. 1 minus sine theta. I just had to answer a question in the symposium where I am. When I manipulate that here, I just had to answer somebody else's question in the symposium where I am. So on the left-hand side, what I do is I find a common denominator, which would be sine theta, which brings this one here up to a sine squared over sine. So I'm going to write that one down. As I build this up to so that the numerator can show sine, that the denominator can show sine. Okay. So now on the left-hand side, I have a common denominator. So I can just write sine theta in the denominator, and the numerator will say 1 minus. So that's what I'm going to write. And at this point here, I'm not going to go any further because now we can see that with the Pythagorean, that the numerator on the left-hand side is the same as the numerator on the right-hand side. So we're pretty much done. We are done. Okay, show that this statement is an identity. This looks like some work. So cosecant theta is the same as 1 over sine theta. Whoops. Yeah. Okay. Sorry about that. There was a word telling me that I did something stupid. Didn't have to do it that loud. And tangent theta is, of course, sine over cosine. And I'll just steal this from the other side, and that way I don't have to rewrite the whole thing. There we go. Maybe put a times in between. There we go. Minus cosine. Okay, all right. This looks kind of neat here on the left-hand side. The sine is canceling. So in the next line, I think I'll push this one up here. You see, this isn't the easiest thing. It's straightforward, pretty much. But you definitely have to pay attention to the algebra. So this is 1 over cosine, and it takes quite a few steps. So the sine theta has canceled out. Okay. Then this one actually really looks similar to the one we had a moment ago, to the other exercise. Because now what we're going to do is that the common denominator is cosine theta, which means the second fraction here becomes cosine squared over cosine. So this one here will be cosine squared theta over cosine. By the way, as I'm typing here and copying and pasting here, I can tell you I'm just about as fast as if I had handwritten this. Because of the copying and pasting, I do save some time. And of course, it makes it look relatively nice. Let's see. So my last step should be that I have a common denominator on the left-hand side. And in the numerator, I'm simply going to have 1 minus cosine squared when I've combined those two fractions. And now at this point here, I can again say, well, that's the Pythagorean. 1 over 1 minus cosine squared is the same as sine squared. So we're done. We are going to go to the graphing calculator, and as I said, I will do the one from a moment ago, the one with the square root x squared plus 4. See if that one checks out, and then we're also going to do these two trig identities on the, or these two identities here on the graph calculator, and just plug in a number, see if that came out correct. Let's see. Here's my graphing calculator. All right, there it is. These keys here on the right-hand side, they might be kind of useful if you want to see what I did here, just in case the cursor moves too fast. I cleared them over there. I think I'm going to clear this one here as well. The stuff in the middle here, that's from a previous exercise that we did quite a while ago. I didn't have the need to use plots since then. So they're just there. Okay, it says square root of x squared plus 4, but it said then substitute 2 tangent theta in there. So I'm going to do 2 tangent, just some kind of number here, 20. There we go. And square this one here. Yep, I'm pretty sure that I closed the parentheses correctly. Add 4 to that. Close the parentheses on the square root, hit enter, I come up with 2.12. That supposedly is the same as 2 times secant theta. Well, I don't have secant theta, so I take it times 1 over cosine 20 degrees, and I come up with 2.12, just like it should be. Okay, notice there were absolute value bars on this one. Watch what happens if instead I choose on, let's see, previous one, this one here, not 20 degrees, but some kind of obtuse angle in the second quadrant. So let's say 105 degrees. There we go, 5 degrees. I come up with 7.72. So notice, when I take the same number and plug it into 2 times secant um, 105. Whoa, I almost was afraid that graphic calculator freezes up on me on the very last stretch here. I'm about a minute. Really, I am a minute away from being done. Notice what happens now. Negative 7.72. That's why they put the absolute value bars around it. So when I do 2 times, and now I have to find where my absolute value is. Let me see. There it is. 1 over cosine 105 parentheses, another parentheses, then I come up with the correct 7.72. Let's see, that's not true. I wanted to do the other 2 trig identities. So let's go and continue on a little bit here. It says cosecant theta, which of course is 1 divided by sine, what do we do here, 33 degrees, minus sine 33 degrees. That's the left-hand side of the trig identity. that we're supposed to show. The right-hand side is cosine 33 squared divided by sine 33 into 1.29 exactly. And the very last one is cosecant, which of course is 1 over sine, what do we do, 88 degrees, times tangent 88 minus cosine 88. And let's see what we come up with. 28.61. And now we're going to do the right-hand side of that identity, and I would be too lazy to type too much. The right-hand side is going to be sine 88 squared divided by cosine 88. Oops. Oh, yeah. I see my mistake here. Okay, I put an extra cosine in here. Whoa, where did that one come from? As I said, that's kind of tough to do here with the using the cursor rather than or the mouse, or rather than the buttons on the graph calculator. I should come up with 28.61, right? There it is, 28.61. With that, I'm finishing this problem section for section 1.5. In fact, this was the last recording for chapter 1.